Welcome to qnawire.
Okay, we have got the phosphorus 3 minus ion. We need to find the electron configuration for it. Now recall that the way we're going to do this is consider that phosphorus 3 minus is simply phosphorus plus 3 additional electrons. So if we can find the electron configuration for phosphorus and then expand it by 3 electrons, we'll be sitting pretty. So what is the electron configuration of phosphorus? That's a good place to start. Well, recall that phosphorus is in row 3, right? So in terms of our noble gases, row 1 has helium, right? Row 2 has neon, okay? And then we're going to say, okay, now we've got our sodium, magnesium, aluminum, silicon, phosphorus, right? Followed by sulfur, chlorine, and argon. Okay. So this is where phosphorus is roughly. It's 3 electrons before argon, right? Which is kind of to say, well, geez, 1 electron more than phosphorus would be like sulfur, 2 electrons more than phosphorus would be like chlorine. Hey, 3 electrons more would be like argon, right? So eventually our electron configuration for P3 minus should look identical to argon. But let's build that up from phosphorus. So recall that to get to helium, we've simply filled the 1s shell. To get to neon, we filled the 2s shell with 2 electrons, as well as the 2p shell with 6 electrons. And then to get to phosphorus, right, first we've got to get through sodium and magnesium, right? That's our 3s2. But then phosphorus is 3 columns in, right, past the non-filled or existent transition metals following magnesium, right? So that is aluminum, silicon, phosphorus, right? So 3p, 3 electrons. That's how we get to phosphorus. And if we're going to add 3 electrons, well, remember, p orbitals can hold up to 6 electrons. So all we've got to do to build it up to P3 minus is fill in 3 additional electrons, turning 3p3 into 3p6. So in total, we should have 1s2, 2s2, 2p6, 3s2, 3p6. Is this one of our options? 1s2, 2s2, 2p6, 3s2, 3p6. Yes, it is. It's the second option.